Okay, so we got journal entry number 3. The topic is scientific method. Down the side of the page, you've written this weird acronym called FEDCA. We're never going to say FEDCA from here on out. Okay, it is just the first letter in 5 key terms that relate to the scientific method. Here's what's cool. Every class has been able to tell me each of those 5 terms on their own without anything coming from me at all. Okay, so this means that this must be a concept that you have some experience with. So what we're going to do is we'll start by, now, you notice on one side of your page, over here on the left side of your page, you've got that place where you take notes. And then over here on the right side of the page, this is where you're supposed to have like pictures, details, stuff like that. That's exactly how we're going to run this page. Over here, we're going to put our basic information on the left, and on the right, we're going to put in an example of each one of these, which will work out kind of well. So if you want to draw a line down the middle, you can. Some kids will fold it, some kids just leave the space there. Doesn't matter either way. Fine. All right, so let's see what you got. Does anybody know any key piece of vocabulary associated with the scientific method that starts with one of those letters? Now, the reason why last class did such a nice job is because not only did they give me the 5 words, but they started giving me other words too that we were able to add to it. And made quite a rich journal. Now, in the beginning, this is always what I get, just like 4 or 5 hands, like, okay, doing that thing. Once you see a couple people do it, you'd be surprised what you know. That's what I think that is. Nico, do you want to try that one, or did you put your hand back down? Okay, do you know one of these? Now, keep in mind, what you're thinking needs to start with one of those letters. So go for it. What are you thinking?
First one.
Yeah, the first one is problem. That's correct. And actually, the first one is not one that most classes get right away. So that's good that you've knocked that one off. The scientific method is a scientific way to solve problems, or like an organized way of solving problems. And one of the first things you need to do is to identify a problem to be solved. Great, now here come the hands. Now all the hands are coming. Okay, what do we got over here? Yeah. H is hypothesis. Now, you're actually giving these to me in order. You do not need to give them in order, but it's fine that you do. Rachel, what are you thinking? It is. All right, so now we're getting through it. C is conclusion down here at the end. So what is E? Here's where kids started giving me words associated with them. That's pretty cool. Yeah, Jonathan, what do you think?
Experiment for E.
Yeah, it is. Experiment for E. I love it. You guys want time to actually run this experiment, which makes it good. Yep. Well, yep.
Did you say data? Did you say data?
Yeah, this is something. This has been the debate of the day. Is data. Okay? Because when some kid says data, half the other class is like, it's data. You fool. But then if the first kid says data, then the other half of the class is like, actually it's data. So we've got a problem here. For some reason, kids want to fight about this, which is fine. I hear it both ways. Don't care. Kids are like, what did you say, Mr. Fay? I'll give you my own honest opinion on this one. I think it's probably actually data. However, I say data. So I don't know where to go. Being a science person, I don't know. If I'm trying to be super geeky, talking to science people, I might say data. If I'm trying to be all cool about it, I'd be like data. I don't know. Sometimes I play both sides. It's the same thing with a lot of science words, though. You gotta listen carefully. There's a lot of science words that are going to be hard to say. You just need to make an attempt to say them, and people will know what you're talking about. All right, lots of science words. You have one teacher, one professor says it one way, another teacher, another professor says it another way. No worries. Data. Both acceptable up here. What's the first one we don't accept? Data. Let's say data. Yeah, that's it. You're done. You're saying data?
You sound British.
Yeah, you sound British, or like you're a toddler calling for their father. Okay, so you do not want to go for that. All right, so let's do something with this. Here's my plan. I say we actually do something with this. Since you know these steps already, we should be able to go immediately to an example. Now, here's where I'm nervous. Because I'm going to have this dynamic where you do something and then I get you back, I do something, I get you back. And most of you are really good, but a couple of you still struggle with this. Okay, because when you talk to each other, you can't stop quickly. So there's going to be a time to talk, a time to not, time to talk. You'll get it. Here we go. I'm going to give you a problem. Sometimes, however, especially in science, the problem is in the form of a question. And we'll address this when we talk about the engineering design brief a little bit. Okay, it doesn't need to be red. You'll see red means it's kind of associated with that term. So sometimes problem will be in form of a question, which is what I'm going to do right now. I'm going to put a problem in the form of a question. And the question that we're going to give you relates to materials you have. You have a golf ball at your table, and you can just leave them there for now. You've got a golf ball at your table. You also have a meter stick that is stuck to the side of the table there. Okay? And what we're going to do is, I might as well just give you the question. We'll say, how does changing drop height affect bounce height? Now, since we don't have a lot of room and it's just our example, we're going to keep this a little bit like cave person talk, okay? And we'll just say, a ball. If you have a little more space and a little more time, I'd be able to write it better than that, but this is fine for now, okay? So there's our problem, there's our question. How does changing the drop height affect the bounce height? Some kids are on me about the effect thing. They're like, actually, isn't the effect with an E? Most of you might be good with this, some of you may not. When it's a verb, it's an A. Like, I affect something. This affects this. That's with an A. When it's used as a noun, it's an E, just so you know. So don't want to correct me on that one. You'd feel weird if you did. All right, so let's go back and check this out. That's the problem we're going to hit you with. Now that we've got that problem, I'm going to have you guys write a hypothesis. But before you do, a couple things you need to realize. You might as well keep it consistent and keep it red. Before you do this, okay, that's really dumb. There we go. Before you do this, you want to make sure that you have something along the lines of an if-then statement. Some teachers require it. Sometimes it doesn't lend itself as well. But usually a hypothesis is an if-then statement. Thank you. Now, if you're one of these guys, but we don't even have like a definition of hypothesis. Does that go in our journal? I say no. Okay, because you have a flippin' vocab. And right now, or at least by tomorrow, you will have a definition for hypothesis. But the pressure's on because that definition is yours. And I hope you chose something good. Okay, so let's go ahead and write that hypothesis at this very moment. I'm going to go ahead and start mine. You can start yours also. In fact, I'm going to let you talk to your group. Why don't you take 60 seconds to write a hypothesis about this question. Again, the question, how does changing the drop height affect the bounce height of a ball? Go. Write a hypothesis. I'll talk to you in 60 seconds. I'm going to write one. If you're clueless, I'm going to write one up here because I want to have some fun too. I started mine. For me, that's the easiest way to write a hypothesis. I always go for it easy, and that's easy to me. I'm just letting you know. I phrased mine like this. I said, if drop height is increased, and then I just put some dots because you can finish that. So if you're looking for a sentence starter, that's a nice sentence structure for writing hypotheses. Okay? You need to make sure that you get going. Oh, yeah. Yeah, about 15 more seconds. You do not have to agree with each other. First of all, we get just one ball. That's done on purpose, so you never have to say the word balls in middle school class.
Okay, what about it? Like, start with that.
5 seconds. So I'm going to have you get silent. This is where it gets weird. You're going to be silent in 5 seconds. And I realize you're having conversations. But you have to be able to wind that down quickly. Cool, done or not. Actually, I don't care at this point. You do need to be silent. If you're still writing, that's fine, but you're writing silently. All right, here's what we got. So we've identified our problem, how does changing drop height affect the bounce height of a ball. We've written a hypothesis. There's the beginning of mine. I did not complete mine because I just want you to have your own. But if you use that as a sentence starter, that's fine. Now we are going to turn you loose for 10 minutes. If you are going to use any of this time off task, you will not finish. And that means that you have an incomplete 10-point page with a past due stamp. So you definitely need to get moving incredibly quickly here. So let's see what we got. We're going to give you 10 minutes to write a quick experiment. Now just take a look. Just take a quick peek here before you get all stressed out. Your experiment can be simple. In fact, I've seen kids write really effective 3-step experiments for how they can see how changing the drop height affects the bounce height. Because they've got a meter stick, the 0 end of the meter stick's on the ground, they got a golf ball, and they're able to just test it right here. So it's a pretty easy experiment to write. What you do want to make sure that you address in here to make it good is you want to make sure you're addressing your variables. Now we're going to talk a lot more about this in later journal entries, but variables are important. In other words, you got to say things like, well, I'm going to drop it from 100 centimeters, and I'm going to drop it from 75 and 25. I'm taking that's actually an independent variable. I'm telling you what the variables are that I'm going to use. Okay? So we definitely want to make sure that we have the variables in here, and we definitely need to use units in here, which I think you're starting to talk about in math class. If you're measuring in centimeters, you need to say you're measuring in centimeters, and that should be evident in your experiment. So I'm dropping it from a height of 17 centimeters or whatever. It doesn't matter what it is, but make sure you state the variable along with the unit. You're also going to have to construct some sort of data table. And that data table is going to have both your independent and dependent variable in it. We'll talk about that in a little bit. Okay, so it can be relatively simple. We're talking about a 9-minute experiment, so this should be fairly easy. But you do need to make sure that your variables and your units are also in that data table. For example, if you're doing drop height in centimeters, you need to have drop height and the unit centimeters there. If you're doing bounce height, you're measuring that in centimeters. The words bounce height, one of your variables, along with the unit centimeters, need to be in that data table. All right, here is our expectation. Let's go ahead and hit this here. This will be perfect. In fact, you're going to get about 1 more minute than every other class, which means we should be able to get through this pretty much perfectly. We're going to give you 10 minutes, and we're going to be the creepers with the motivators. Yeah, okay. And again, we've got all but 2 marks on motivators being positive today, so we've got no issues. What we're going to do is we're going to turn you loose. Your group must write a few-step procedure or experiment that you're going to do, but it doesn't need to be 3. It could be 4, whatever. That's fine. 2 might be tough, but I'd say at least 3. And then you got to construct like the world's simplest data table, but make sure you got variables and units and stuff in it. Come back to me with a conclusion. You're going to have to give us a conclusion before you leave today about how changing the drop height affects the bounce height. So I'm going to let you go right now for 9 minutes with your group. Write it, test it, make a conclusion. Any moment off task, you're getting marked, and you will not finish. So go ahead. Good luck to you. I wasn't going to say it like that. I'm going to use exactly what you said. Okay, we've got all groups really but 1 done. You guys are just finishing up conclusions right now at this point. Is that where you are? Okay, so I'm going to go ahead and get started. Group 6 may still be whispering a little bit. Everyone else at this point is going to be completely silent. All right, let's go ahead and share out. Let's see if we can get a conclusion. But I want you to keep something in mind about what makes a good conclusion. And I think, Kyle, you started to say something. I think I kind of know what it's going to be, but I'm not sure. What makes a conclusion like a really strong conclusion?
You say the data did or did not support your hypothesis.
Yeah, you got to make some sort of reference to your data. That's what makes your conclusion over the top. Elementary school conclusions might be, you know, like my hypothesis was right or my hypothesis was wrong. I might restate it. But really good conclusions. And here you go, Maida. You can be happy. They cite data. So in other words, they make reference to their data. So they say how their data supports it or does not support it. So I'm just curious, does anybody in here have a conclusion written that makes reference to their data? Okay. Anybody want to share one? Anybody want to share one? Yeah, let's go for it. Rachel, what do you got?
In conclusion, if a ball is dropped at an increased rate, the bounce rate will become higher. The experiment proved this hypothesis correct because the data showed that when we dropped the ball from 100 centimeters, it bounced the neck.
There is absolutely nothing I could do to critique that because it was absolutely perfect. Okay? That right there is probably one of the higher level conclusions I've ever been given. So great stuff. Before you rush on out, make sure you take your yellow sheet and place it inside the binder in the correct order. Just don't damage the place because you don't want to lose it. Take it easy. Have a good one.